being titrated against the base in the beaker. So as you are gradually losing this opening, you lose this opening gradually, such that the acid begins to drop little by little. And in order to avoid error due to parallax, you must ensure that your eye is in line with the setup. So in that situation, as the acid begins to drop, there will come to a stage where the volume of the acid in this beaker is equal to the volume of the base. At that point, the point is called the equivalence point. And at that point, you have to be observant, because any moment from that point, you attain the end point. So, end point is attained when the volume of acid is slightly greater than the volume of the base. And that is known as the end point, where you observe a change. So this is the setup for volumetric analysis. With respect to the previous volumetric analysis setup, it can be deduced that this table is applicable where you have your burette reading, final burette reading, initial burette reading, volume of acid used. It must be noted that these parameters has to be in, each one has to be in centimeter cube. The unit of the measurement must be stated clearly in the table. Then this is your first titer, the second titer, the third titer. In the first titer, assuming that we have 32.20 cm cube for the final burette reading, that is when the color is observed, that is the end point. Then it is started at 0.00 initial burette reading. Then the second case, second titer, 32.19 under the same unit with the initial burette reading 0.00. Then the third titer, 32.30 cm cube, while this initial burette reading is 0.12. So when we subtract this from this, we have this. When we subtract this from this, we have this. When we subtract this from this, we have this. So these are the respective volume of acid used in first titer, second titer, and third titer. Now we are to look for the average titer, and the average titer is simply the addition of the first titer, that is the volume of acid used in the first titer, plus the volume of acid used in the second titer, plus the volume of acid used in the third titer. And that can be written as 32.20 plus 32.19 plus 32.18 divided by 3. And this, you must ensure that it is expressed in centimeter cube, where the final answer will now be 32.19 centimeter cube. So this is the average titer for this table. Under volumetric analysis, calculations in acid-base titration. Number 1, in a titration exercise involving sodium triiodocarbonate 4 as solution B and tetraosulfate 6 acid as solution A, using phenolphthalein as indicator, 25 cm cube of 0.1 molar of B was completely neutralized by 23.45 cm³ of A. Calculation designed for this: calculate 1, the concentration of A in mole per dm³. 2, concentration of B in gram per dm³. So, going by that, the first thing we have to do here is to write the parameters that are given. In the question number 1, it has been established that solution B is sodium trioxocarbonate, which is a weak base. Again, solution A, which is solution A is H2SO4, which is the acid. The volume of the base and acid are also given. Recall that CaVa over CbVb is equal to Na over Nb, where Ca is equal to the concentration of acid in mole per dm³, which is Ca. Cb is equal to concentration of base, also in mole per dm³, where Va is equal to the volume of acid. Vb is volume of base. Na, mole of acid, number of mole of acid, while Nb is number of mole of base. So owing to this, it can be deduced from the calculation that Ca is what we are asked to look for. It is not given. Cb is given in the question as 0.1 mole per dm³, while Va is given also in the question as 23.45 cm³, which is the same thing as 0.002345 dm³ by dividing it by 1000. Then volume of the base is 25 cm³, which is the same thing as 0.0025 dm³. Number of mole of acid, that can be deduced from the reaction. Number of mole of acid and number of mole of base can be deduced from the reaction. And this is sodium carbonate reacting with H2SO4, where you have Na2SO4 plus H2O plus CO2 as the product. So in this situation, it is 1:1 ratio. So, resulting to this formula, in calculating the concentration of acid in mole per dm³, then we have Ca, which is not known, times Va. Va is 0.002345 divided by Cb, 0.1 molar, which is mole per dm³, times Vb, that's 0.0025, equals to 1:1. If you make Ca the subject of the formula, it will be Ca equals to 0.1 times 0.0025 over 0.002345, which is equal to 0.106 mole per dm³. So the concentration of acid in mole per dm³ is 0.106 mole per dm³. So that is the concentration of acid in mole per dm³. 0.106 mole per dm³ is Ca, which is the concentration of acid. Question 1, Roman figure 2. Concentration of B in gram per dm³. It has been established that concentration in gram per dm³ is equal to concentration in mole per dm³ times molar mass. And from the question, we are asked to look for the concentration of B in gram per dm³. Molar mass of Na2CO3, which is the base, is 2 of 23, because sodium is 23, plus carbon is 12, plus 3 of 16, which is oxygen. So this is 46 plus 12 plus 48.